Hi everybody, this is a proof of the following Laplace transform, that the Laplace transform of negative t times f of t is equal to f prime of s. And just to recall that in this notation we are saying that the Laplace transform of f of t is equal to capital F of s. So this is going to be some function that we know the Laplace transform of, except there's a negative t in front of it. And we'll be able to evaluate that Laplace transform by taking the derivative of the Laplace transform for f of t. So we'll look at a proof of this, and the proof, to me, this is not necessarily obvious. There are lots of Laplace transform proofs that I know off the top of my head, but this one I had to kind of look up and remind myself because this one to me isn't as obvious. So the idea is that we're going to go back to the definition. So that is that the Laplace transform is equal to the integral from 0 up to infinity of e to the negative st times f of t dt. So that is just definition, day one of Laplace transforms. That is what we came up with. And then what I'm going to do is take the derivative of both sides with respect to s. So d ds of f of s is going to be equal to the derivative with respect to s of the integral from 0 to infinity of e to the negative st f of t dt. So on the left side, clearly, I'm just going to get f prime of s, which is what I have on the right side of my proof up there, or of my result up there. On the right side, what I'm going to take advantage of is that this is a derivative with respect to s, and this is an integral with respect to t. So everything that has an s in it is a constant in the integral, which means that I could move that derivative inside of the integral. So let me give myself a little bit more space here. I'm going to rewrite this as the integral from 0 to infinity, and I'm going to rearrange what's inside of that integral a little bit. I'm going to write the f of t first, and then d ds of e to the negative st dt. And I'm allowed to move that in there because of the fact that f of t doesn't have an s in it. So when I take the derivative with respect to s, that's going to be treated like a constant. So now what's inside of this integral here? That is just a derivative, and that's a pretty straightforward derivative. So I'll get the integral from 0 to infinity of f of t. Now the derivative of e to the negative st with respect to s is going to be up here, the chain rule is going to give me a negative t times e to the negative st. So that would be the derivative of e to the negative st with respect to s dt. And then the last thing that I'm going to do is I'm going to rewrite this as the integral from 0 to infinity of e to the negative st times negative t f of t dt. And remember, on the left side, I've already gotten that this is the derivative of f of s. And so what I have here, this is the Laplace transform of negative t times f of t. That's going back to that definition of the Laplace transform. So what I get is that f prime of s is equal to the Laplace transform of negative t times f of t. And that proves the result.